All right, section 3.2 is the one that we skipped before Christmas because it has all the calculator stuff in it. We are going to talk today about something called end behaviors and multiplicity. That's the only thing that is new today. Everything else is finding the zeros, which would be using the rational root theorem, the P over Q, synthetic division, that sort of a thing. You have to find additional points on a graph. These questions are not incredibly difficult, but they are lengthy. All right, there's a lot of steps to them, so you just need to make sure you're paying attention to what you're doing and taking your time. But your calculators need to be here tomorrow, okay? I am not doing every example in this lesson today. The ones that say you need a graphing utility, I will do tomorrow, and then we just have some extras that we're going to practice. But I need you guys to get these concepts down today. We're going to first talk about end behavior. And what that means is what the graph is doing at the ends. What direction are the arrows going? All right, and there's two options. You're either going to have them going in opposite directions or they're going to be going in the same directions. Very, very simple, very straightforward. How I want you to think, okay? If your polynomial, the highest degree is odd, then the direction of your arrows, if it's odd, is going to be opposite. All right, that should be easy to remember. And if the highest exponent is an odd, I want you to think like a line. What does that mean? Think like a line. Is this going to make the shape of a line? No. But the ends of the graph will look like a line. So think it in your mind. Visualize a line. A positive line slopes upwards like this, right? You guys agree with me? And a negative line slopes downwards.
For the graphing calculator, I'm going to need something more advanced than this,
yeah.
Right? Okay. I think I have one.
Okay. So if your leading coefficient, if your x cubed, your x to the fifth, your x to the seventh is positive, the ends of your graph are going to mimic a positive line. It's going to be going down on the left-hand side and up on the right-hand side. How you would write that is you would say, because we always read a graph from left to right, so your end behavior would be falling left and rising right. And we're going to do a bunch of examples, and by the end of this, you're going to be like, oh my gosh, this is so easy. Can I have a million questions like this? All right, so now to identify end behaviors, you look at your highest exponent. If the leading coefficient happens to be negative, you think about the ends of a negative line. So we're going to do the exact same thing here. We're going to look from left to right. So I'm going to look on the left-hand side and then on the right-hand side. What is the left-hand side of this graph doing? Is it going up or down? Up. So it's rising on the right and doing what on the left? Rising or falling? Falling on the left. Good. So if your highest exponent is an odd, 3, 5, 7, 9, whatever, you think like a line. If it's a positive line, it slopes upwards. Negative line slopes downwards. So you think about what the directions of those arrows are. If you have a function that is of an even degree, what's an even degree? 2, 4, 6, 8, right? X to the fourth, X to the sixth. It's much easier. If you have a positive, you're always going to think like a parabola. What do the ends of a parabola do? They both go where? Or down. So if it's positive, what's your end behavior? Both going up. If it's negative, what's your end behavior? Both going where? So if it's a positive, your end behavior would be rising right and rising left. If it's negative, it's going to be falling on the right and falling on the left. Now, some of you guys are like, why is this important? Because you are going to take a polynomial. You're going to find all the zeros. You're going to find the y-intercept. You're going to find some additional points. And then you're going to graph it. And you need to know what directions the arrows go so you know where to start, where to end. Very important. All right, next thing we're going to talk about. We already know, we talked about zeros already. That's over with. You guys already know that. Zeros, right? How do you find the zeros? You set f of x or y equal to 0. And when you find the zeros, you're also finding the roots or the solutions. Those words mean the same thing. And each real root It could be gnarly looking. It could be like square root of 29 or whatever. But each real root is an x-intercept. Crosses the x-axis. Do all roots cross the x-axis? No, only the what ones? Only the real ones. What if you had x equals 2 plus or minus 3i? That's an answer. That's a solution. But is it a x-intercept? No, because you can't put that on a graph. So just pay attention to that. And then the last thing I want to talk about here is something called multiplicity. All right, now multiplicity, how many times you have an answer to something tells you what happens at the x-axis. So if you have multiplicity an even amount of times, what does that look like? Say you factored your problem and you got x plus 2 times x plus 2, right? And I said, well, what are the zeros? What does x equal here? X equals negative 2. But how many times do you have negative 2? 2 times. Is negative 2 2 times? Is that an even amount of times you have it or an odd? It's even. So this is going to do what's called bounce off the x-axis. If you have the same answer an even number of times, you got x equals negative 2 twice, you got x equals negative 2 4 times, something like that. When you graph, it's going to bounce off, and I'll show you what I mean. Say you got this as an answer. Right? You're going to find the zeros. What's one of the zeros? X equals 1. What's another one of the zeros? X equals negative 3. How many times do you have negative 3? 3 times, okay. How many times do you have 1? 1 time, okay. 3 and 1, are those even numbers or odd? Odd. If you have an odd number of times the same answer, it's going to cross through the x-axis. You'll see what I mean in 1 second. So if you were going to graph this, all right, we'll pretend like we just solved this. We had how many answers? Well, 4 here, and then we'll count this one up here. Well, there's 4 here, and how many answers up here? 2, right? So a total of 6. So let's just say I got negative 3, negative 2, and 1. You guys agree with me? All right, so what did you tell me is going to happen when the graph touches negative 3 and positive 1? It's going to go through the x-axis. What's it going to do at negative 2? Bounce off. What that would look like is you would go through negative 3, come back down to negative 2, and bounce in this other direction, and then you're going to come down like this. You'll be able to tell how high and low you go. I'm going to show you how to find additional points and stuff like that. But that's what that means. To cross through means it actually goes through the x-axis. This is bouncing where it touches it and goes the opposite direction. And the reason that occurs is that multiplicity of an even number of times. Let's put this into real life. So what Miss Corey did was all of these examples she put into a graphing calculator. This is Desmos. And it shows you exactly what the graph looks like. You guys are going to be given a calculator portion and a non-calculator portion on your test. So you're going to have to do them by hand. One of them, you'll have a calculator that you'll be able to kind of check and see where it is. One of them, you won't. So in this case, let's look at this and pretend like we don't have our calculator. We're going to find the end behaviors, the zeros, and multiplicity. All right. The last period asked, how do you know how many times it's going to like turn, go up and down and up and down? The number of turns you have is the highest exponent, which is what here? 3, and then you take 1 away. So how many bumps is this going to have when I go to graph it? 2. It's going to have 2 little bumps. It's how many like turns the graph's going to have. It's always the highest exponent minus 1. All right, so first thing let's talk about is the end behavior. How do we find end behavior? We identify the highest exponent. What is it? 3. Okay, 3 is an odd number. So I think opposite. Now look at the leading coefficient. Look at the coefficient in front of x cubed. Is it positive or negative? Positive. Okay, so we're going to think like a positive line. So I'm just going to draw a little positive line. Here's my left-hand side. Here's my right-hand side. What's it doing on the left and what's it doing on the right? It's falling where? On the left and rising on the right. Perfect. So now I know when I go to graph it, on the left-hand side, it's starting from negative infinity. On the right-hand side, it's ending at positive infinity. Does that make sense? So you gotta have an idea. So then our next thing is to find out, well, where does this cross the x-axis? How many zeros are hidden inside this problem? 3. I know there's 3. First thing I would try to do is group it. It doesn't group. So if it doesn't group and we have to find all the x values, what do we have to use? Let's just pretend like it doesn't. We're not, let's just pretend. It does, I know, but let's just pretend like it doesn't. Anybody? How would we do this? What would we do? Okay, let's group this one. We'll do P over Q in the next one. If it groups, we love it. 98% of yours won't, but we'll just go through. So I'm going to take out x squared here, yeah? I'm left with x plus 2. I'm going to take out here a negative 4, and I'm left with x plus 2. Okay. So I have x plus 2, and then I have x squared minus 4. So x plus 2, and then this breaks down to plus 2 minus 2. You guys agree? Okay. So what are my x values? I have x equals negative 2, x equals negative 2, and x equals positive 2. Agreed? What do you notice? So what's going to happen here? You have multiplicity here. How many times? Twice. So what happens when you have an even number of multiplicity? What's going to do at the x-axis? It's going to bounce. Perfect. I have this one time. So what's it going to do at the x-axis? Cross through. Perfect. All right, so we have our x-intercepts. We have our n behaviors. A couple other things we need to find. We need to find your y-intercept. What's your y-intercept? Negative 8. Good. So your y-intercept's at 0, negative 8, just the constant. And you are going to be asked, guys, for additional points. How do you find additional points? Let me show you. If we're going to graph this, I know I have intercepts at positive 2 and at negative 2. And what did we say our end behaviors were from the very beginning? Falling on the left, right? And rising over here on the right. Okay. And then I have an intercept here down here, right? So I have it here and here. To find additional points, you want to find something that's in between your intercepts. So pick a number or numbers on the x-axis that are in between negative 2 and positive 2. Okay, you want to pick 0? You guys could pick, say they said 2 additional points. So let's do negative 1 and 0. Want to do that? Actually, don't use 0. For the way that we're going to do this, don't use 0. We'll do negative 1 and positive 1. So how do I find out what the additional point is? You use synthetic division. If I use synthetic division, negative 1, and I have 1, 2, negative 4, and negative 8, right? So let's do our synthetic division. Bring down 1. This is negative 1. 2 minus 1. 1. Negative 1. You guys get the same thing? Okay, so when I plugged in negative 1 to my synthetic division, what did I get out as the y value? Negative 3. There's an additional point. So I have an additional point at negative 1, negative 3. So you know how high and how low to go. So let's pick another one. Let's pick positive 1. All right, it becomes hard when you have to use a fraction. I understand that. Again, those will probably ones that you have a calculator for. So 3, negative 9. So this additional point is what? 1 comma negative 9. So I'm going to go 1 and then negative 9. So let's talk about our graph. We're going to draw a picture of our graph. What did we say? Again, what's going to happen at negative 2 and what's going to happen at positive 2? It's going to bounce off at negative 2 and go through positive 2. So it goes up to negative 2, it bounces off, come back through these additional points, and then goes back through. Those additional points tell you how high and low to go on your bounces. But the way that you find the additional points, guys, is you just plug in anything on the x-axis that's in between intercepts. And we'll do a bunch of these. Yep. Just plug in your original problem, plug in 0 for all your x's. It's always the constant. All right, so let's run these examples. Here's your strategies for graphing. These are some things you need to do. The first thing we need to do, guys, every single time, we're going to determine the end behavior. We're going to figure out which direction the arrows of the graph are going. The second thing we're going to do is find the zeros, find the x-intercepts, find the solutions, and then figure out what happens because of the multiplicity. Does it go through or does it bounce off? We can find the y-intercept. That's just setting all the x's to 0. And then plot additional points. How do you find additional points? You just pick something on the x-axis that's in between intercepts, and then use synthetic division, the remainder theorem. Whatever the remainder is, that's your y value. So again, I'm not doing all of them. I'm going to skip through some. All right, let's do 2. Let's talk about end behaviors first. I always like to go in order. So my end behavior. Highest exponent, odd or even? Odd, so I think odd opposite. If it's odd, we think like a line. Is that a positive x cubed or a negative 1? Positive, so it's going to look like this. So if I were to look at this from the left to the right, what is my end behavior? It's falling where? Left and rising right. You always look left to right. Same way we read a graph. Good. All right, so the next thing I'm going to do is I'm going to find the zeros, see if there's any multiplicity. Can I group this? No. If you have more than 3 terms, you can't factor it. We can't use the quadratic formula. We have to do our P over Q. So you're going to take the last over the first. What's the last number? 6. Over the first is 1. So I need all the factors of 6. It's going to be plus minus 1, 2, 3, and 6. Remember, we did this before the break. I'm going to use those factors, and as soon as I get a remainder of 0, what did I prove? What does the remainder of 0 mean? That it's a factor, it's a 0. So let's just start with 1. If 1 doesn't work, go to negative 1. So I have 1, negative 2, negative 5, and 6. 1 times 1 is 1. Negative 2 and 1 is negative 1, right? Negative 1 and 1 is negative 1. Negative 5 and negative 1 is negative 6. Negative 6 and negative 1 is negative 6. What did you guys just prove? That's a factor. So one of my answers is x equals 1. One of my zeros, my intercepts. What is left over here? Perfect. X squared minus x minus 6 equals 0. Before you jump to the quadratic formula, what should you try to do? Try to factor it. Are there factors of negative 6 that multiply to give you negative 6, add to give me negative 1? X minus 3, x plus 2. Perfect. So what are my other 2 x values? X equals 3 and x equals negative 2. Okay, did you find all 3 of them? Yes. Do you see any of them a repeated number of times? No. So what's going to happen at all 3 of those points on the x with your graph? What's going to happen? It's going to cross through. Good. What's the y-intercept, guys? Perfect. So 0, 6. So I have positive 1, positive 3, right? And negative 2. All right. And what did we say our end behaviors were? Falling on the left-hand side, rising on the right. And it's going to cross the y at 0, 6. So 1, 2, 3, 4, 5, 6. Good. And then let's find 2 additional points. Well, pick something in between -2 and 1. What number do you want to do? Don't use 0. -1, okay. And then we'll also use what? 2, okay. So how do we find the additional points? We just come over here and we do synthetic division with -1. So it's 1, -2, -5, and 6. Negative. You guys get 8? Okay, so I have a point at -1, 8. And then if I do 2, -4? Yes or no? 2, -4? All right, so -1, 8. -1, 8. And then 2, 1, 2, 3. So this tells you how high and low to go. And now we just connect. Because again, at the x-axis, what are you doing at each point? Because you have each one of them one time, you're going through. So just go up, here, back down, go back through. So you know when you go up and down, Alec, through your intercepts and stuff like that, you know how high and low to go. These are just examples from Desmos. Okay, I'm going to come back to this one tomorrow. But how would I find the possibilities for this one? Last over first, so I have to put plus minus 12 over 2. And then it could be fractional answers, that sort of a thing. We're going to deal with fractions in the next couple days. You're also going to deal with your calculator. We'll come back to it. All right, I'm going to go through this one quickly, very quickly, and then I want to get to a couple more. And then we'll be done. But let's talk about our end behaviors. Let's talk about end behaviors in this graph. Somebody asked last period, is it always odd and to the third power? No. This just happens to be like that in these examples. But what's the highest exponent you see here? 3. So I think odd and opposite. Think like a line. What do you notice about the leading coefficient? It's negative. So it's going to be going like this, correct? So what is our end behavior? What's happening on the left? What's happening on the right? It's whoa, bad color choice. It's rising on the left, good, and falling on the right.
It's going down because the end behavior is -1, right?
Correct.
What is end behavior?
It's what the ends of the graph are doing. All right, so now we need to figure out what the zeros are, where this crosses the x-axis, if it does at all. How do we do that? Can I group this? No. So I have to use the factors of 20. So plus minus 1, 2, 5, 10, and 20. This is one that you really hope 1 or -1 works. So let's start off with 1. So -1, -8, -11, and 20.
Wait, what's the formula for the last number and the first number again?
You just put the last one over the first.
Shouldn't they be negative then?
You're always going to use plus minus, so you're accounting for the negative or the positive. Yeah, I just know we don't need that one when we're doing this. So yeah. All right, so -1. -1 times 1 is -1. -8, -1, -9. -9 times 1 is -9. -20. All right, what do we show here? We're going to cross at x equals 1. All right, good. So what do I have left over? -x squared minus 9x minus 20 equals 0. Do I ever have you guys factor when you lead with a negative? No, 90% of you don't ever get this right. So let's take out that -1. Then we have x squared plus 9x plus 20 equals 0. Can you factor that? Factors of 20. That multiply to give you 20 and add to give you 9. Perfect. X plus 5 and x plus 4. And now how do we get our answers? We set each piece equal to 0. So -1 equals 0. Ever? No. So I have x equals -5 and I have x equals what? -4. All right. How many answers did you guys find? 3. How many did we say there were at the beginning? 3. Okay. How many times do you see each one of those? Just one time. So what's it going to do at each one of those? Cross through. Good. What is the y-intercept? All right, your y-intercept is going to be at 0, 20, right as a point. So could we graph this? Very easily, guys. You're going to say, okay, I'm at -5. I'm at -4. And I'm at +1, right? What were the end behaviors? Rising over here and doing what? Falling over here. Now this one is hard to find additional points for. I would imagine if you had something like this to find an additional point, you'd have your calculator. Because is it easy to find an additional point between -4 and +1? Yeah, you can plug in -3, -2, -1. What's going to happen here to find something in between? It's going to be a fraction. So you'd have to use synthetic division with a negative fraction. I would imagine something like that. If you have to, you'll have your calculator. But if you do find an additional point with -1, it happens to be at 24. I just already did the math for you. So it's like way up here. So let's draw our graph, okay? It's going to come, and then, so say 20 is right there. It's not really, but you know what I mean. So we're going to come down, through, and then through. The concept, the process of how to find all of these is what I really, really, really need you guys to grab a hold of. So the next couple we're going to go through fairly quickly because we're getting the hang of it, but they're going to just show different kinds of problems that you might see. Yep. Okay, again, we keep repeating the same thing I know about end behaviors, but end behavior on this one, highest exponent? 3. So when I see 3, I think opposite and what? Odd. Is that a negative x cubed or positive 1? Negative. Good. So something like this. So what are the ends doing? It's rising on the left. Always go left to right and falling on the right. All right. Perfect. So now we got to figure out where this graph crosses the x-axis, if it does at all. All right, how many answers are we going to find? Whether they be real or imaginary, how many answers are we going to find? 3, okay? This does not group, so we're going to have to use P over Q. Last over the first, so plus minus 2 over 1. I need all the factors of 2. It's going to be plus minus 1 and 2. Can I save us a little bit of time? Okay, because what's going to happen? You guys are going to start with 1, and synthetic division is not going to work. And they're going to do -1, it's not going to work. Then you're going to do +2, and it's not going to work. But when you do -2, it does work. Because I've already worked this out. I'm just trying to save you guys some mental anguish on the first day back from Christmas break. I know sometimes synthetic division is annoying to you, and sometimes it can be frustrating when you don't get 0 as a remainder, so just helping out. So go to the corner. -2 times -1 times -2 is 2. 2 plus 2 is 4. 4 times -2 is -8. 9 minus 8 is 1. 1 times -2 is -2. 2 minus 2 is 0. So we found out that x equals -2. Okay, so what am I left with? -x squared plus 4x plus 1 equals 0. Without even factoring out the negative, is this going to factor pretty? No. So if you get to a quadratic that doesn't factor pretty, what do we have to use? The quadratic formula. So A here is -1, B is 4, and C is 1. We haven't had to use this yet. So quickly get our quadratic formula. You have -b plus or minus the square root of b squared minus 4 times 1 times 1, should be -1. And then all over 2 times -1, right? So as we simplify, -4 plus minus 16 plus 4 over -2. -4 plus minus the square root of 20 over -2. Does 20 break down? 4 and 5. So -4 plus minus 2 root 5 over -2. And then we can simplify a tad bit more. So x equals -2. No, that'd be positive. X equals 2 plus or minus the square root of 5. Are those two answers there? Yes. Are they real? Yes. Are they beautiful? No. But you can put all three of these on a graph. Okay, that's important for you to understand. Now, some of you are like, how am I supposed to know where that is? The square root of 5, what is that close to? The square root of 4, which is 2. So this is like 2 plus 2-ish and 2 minus 2-ish. So if we're going to approximate on a graph, what is 2 plus 2-ish? 4-ish, right? And what is 2 minus 2-ish? 0-ish. Okay, so I'm going to go to my graph and I'm going to say, okay, I have an intercept at -2. I have an intercept at, -0-ish. And I have an intercept at 4-ish. Correct? What's my y-intercept? Okay, your y-intercept is going to be at 0, 2. So 0, 2, I know it's going to cross right there. And then can we find additional points? What would be an additional point between those two intercepts? Plug in -1. And then what could I do on the right-hand side? 1, 2, or 3. Doesn't matter. For time's sake, if you did -1, your additional point would be -1, -4. And if you did +1, it's 112. Just for time's sake. I know you guys can all do that. Yep. So if you were to plot these additional points, so -1, -4, and then 112, it's like way up here. And you're to, what are my end behaviors again? Rising on the left, falling on the right. And then what's going to happen at each one of these? How many times did you see each one of these answers? Just once. So it's going to do what at each one of them? It's going to cross through. So you're going to cross through, back up here. Boom. If you see the same answer 2 times, what's it going to do at the x-axis? It's going to bounce. All right. 11 minutes. Okay. I'm going to do 2 more examples. I'm going to look at one of my intercepts. Agreed? What just happened? All right. First thing, I'm just going to talk through this one. But on 7, when I first looked at this, everybody's like, what? This is actually easy because it's already factored for you. All right. Do you guys agree with me that this parenthesis is x to the first power? Okay. This is to the second power and the other one's to the second power. So how many zeros here are there total? 5. There's 5 zeros. There's 2 here, 1 here, and 2 here. All right, so there's 5 zeros. Everybody see that? 5 zeros. Okay. It's an odd number, so it's going to be odd. It's negative, so it's going to be rising left, falling right. But let's talk about these zeros. How many x minus 3s do I have? 2. So I have x equals 3 how many times? 2 times. How many x plus 1s do I have? 3. Okay, so I have this 3 times. So if you were going to graph this, guys, what's going to happen here at the x-axis? It's going to bounce. What's going to happen here at the x-axis? It's going to go through. It's going to bounce at x equals 3 because there's 2 of them. If you have an even amount of multiplicity, it's going to bounce. If you have an odd amount, so here you have x plus 1 3 times, it's going to go through. If I asked you guys to find the y-intercept, how would you find the y-intercept for this problem? How do you find the y-intercept? You plug in 0 for the x's. So you would plug a 0 in here, and a 0 in here, and a 0 in here, and you'd have to do some math. When you do that, you get 0, -9. So your graph, since it's an odd, it's going to have opposite end behaviors, and it's negative, so it's going to be rising on the left, falling on the right. You have intercept at -2, and you have one at +3, and then you have your y-intercept here. So if you were going to draw this, what is happening, guys, at -1 and what is happening at 3? What's happening at -1 on the x-axis? What's happening at 3? Okay, it's going to go through -1 and do what at -3? Bounce and come back down. Because I messed up. I'm trying to go fast. Yeah, I'm trying to get the last example done before the bell rings. What time is it? It's 10:52. What you guys need to take away from today is what happens at the x-axis based upon how many times you have an answer, a solution. If you have an even number of multiplicity, it's going to bounce off the x-axis. If you have an odd number, it's going to go through. Let's do this last one, and then we're done. Let's do this last one, and then we're done. We'll pick up tomorrow. You've got to have your calculators tomorrow. Okay, end behaviors. Quickly. Okay, highest exponent is odd, so I think opposite directions, correct? Is my leading coefficient positive or negative? Positive, so I'm thinking of mimics a positive line, the ends do. So what is my end behavior from left to right? Falling left, perfect. And rising on the right. All right, so now let's go ahead and do find the zeros. This is not going to group. So you have to do your P over Q, your rational root theorem. You have to have all the factors of 1 and 7. Let's try 1. So, synthetic division. If 1 gives us a remainder of 0, then it's a factor. So we know it's good to go. 1 times 1 is 1. 6 plus 1 is 7. 7 times 1 is 7. This is 19. Is this going to give me 0? Okay. So just move along. Don't waste your time. 1, 6, 12, and 7. -1, this is 5, -5, 7, -7. What'd you guys just prove? Okay, so x equals -1. What is my resulting polynomial here? X squared plus 5x plus 7 equals 0. Is that going to factor? So we need to use the quadratic. So x equals -5 plus or minus 5 squared minus 4 times 1 times 7 all over 2 times 1. So -5 plus minus 25 minus 28 over 2. So when we simplify this, we get -5 plus or minus the square root of -3 over 2. What do you guys notice about that? It's imaginary. So I have here x equals -5 plus or minus I square root of 3 over 2. Is that 2 additional answers? Yes. But can I plot that on my XY? No. So some questions tomorrow you guys are going to get, and you're going to visually see that the graph crosses like one time. But it's x to the third power. So instead of thinking, oh, I did something wrong on my calculator, what should that indicate to you? You have 1 real and 2 what? Imaginaries. Oh, thank you. 1 real, 2 imaginaries. All right. Just because you don't see it doesn't mean it doesn't happen. It could be an imaginary solution, something like that. So I just want you guys to be aware. Sometimes they factor beautifully. Sometimes they're not so great, but you can still put them on a graph, and then the imaginary ones you cannot. Make sense? Okay.